Now let us study about image formation by refraction at plane surfaces. We already studied about image formation by refraction at spherical surfaces. So here we can write for plane surfaces we use the radius of curvature to be equal to infinity. Now if the radius of curvature of a surface is infinite, we can write by refraction formula we have mu2 by v minus mu1 by u is equals to 0, or we can write mu2 by v is equals to mu1 by u. Or image location, here we can calculate by using just the rearrangement as u multiplied by mu2 by mu1. This is the relation we use for image location by using refraction at plane surfaces. Let's have a look on two situations. If for this plane surface, if this is medium mu2 and this is medium mu1, and in this situation say if mu2 is greater than mu1, and if an object is placed at a depth h below the plane boundary, and here if mu2 is greater, then we can directly state that the second medium is denser, so whichever light is incident on the boundary, it will bend toward normal, and this will be a diverging light ray with respect to its principal axis, and it appear to be coming from a point which is behind the location of object, and this point can be considered as image where all refracted rays appear to meet. If we draw many refracted rays, these all rays appear to be coming from this point, which will be considered as image of this object. So if this height h is the object distance, the image distance can be given as h dash, and the value of h dash here we can directly write by using h dash is equals to h multiplied by mu2 by mu1. So this is the way how image can be obtained, which is displaced far away from the boundary if light is going from a rarer to a denser medium. And in the second situation, say if this mu1 and this mu2 and we consider mu2 to be less than mu1, then we can see in this situation if this is the object placed at a depth h below the boundary, and a light ray is incident onto the boundary, it will be deviated away from the normal after refraction, and it appears to be coming from this point, which will be treated as an image located at a distance h dash from the boundary. Now all the rays which are refracted from the boundary appear to be coming from this point, provided here we are considering all these rays to be paraxial rays, because the refraction formula is only valid for paraxial rays. So here we can write h prime is again equals to h multiplied by mu2 by mu1, but here the value of this h prime is less than h, or we can say the image of object is displaced near to the boundary from which refraction is taking place. But one important thing here you can see, if u is considered to be positive in this situation, that implies the value of v is also positive. And if u is taken negative, this implies the value of v will also be negative, because on the two sides of equalities, signs must be same. And this implies by refraction at plane surfaces, always image is produced on same side of object. In whichever medium the object is placed, in the same side image is produced when it is seen from the other side.